Okay, the quadratic formula, and I'm throwing in the discriminant in here also. So the quadratic formula, you've seen it probably a million times, and you should already know it. So this is just an oh yeah for me and for you. Okay, so I'm not going to go super deep into it, but you do have to deal with some problems that are a little more difficult. So remember, it's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and there's songs that go with it that you can sing, and I just refuse to sing to you because it would be really bad and that would just be wrong of me. So maybe I'll sing in class when somebody will join me. Anyway, so this is what you have with the quadratic formula, and it goes with all this ABC stuff is just that standard form that we talked about in the last lesson. So standard form is ax squared plus bx plus c, okay, equals 0. Has to be equal to 0 for the quadratic formula. What you're trying to do in the quadratic formula is get the roots, just like the roots we did that we found with completing the square. So in completing the square, a lot of times we ended up with plus or minus something, right? And so we're going to end up with the same types of things with the quadratic formula. And right now you're going to like quadratic formula better because you're more familiar with it. But as you complete the square, you're going to see that completing the square, you can suddenly almost kind of do them in your head. So you'll get pretty good at those. So anyway, well, let's talk about quadratic formula. So here's the first one I'm going to do. Now I'm going to discuss discriminant in this too. So I'm doing two things because I don't really think that we need to really go into quadratic formula a whole heck of a lot. Okay, so here's my first one. So here is an example. So I'm going to solve the whole thing and then I'm going to talk about the discriminant. Okay, so here's my example. So what I have then is the opposite of b, and you know, even in the song we always say the opposite of b because it truly is the opposite of b, because b could be negative, and right here I have b is -5, right? So it truly is the opposite of b, and the way we show it is the opposite of b. Okay, so then you know that it's going to go positive, right? If you look at it like that. Plus or minus the square root of b squared, so I have -5 squared minus 4 times a times c. Now don't forget your signs, that's what will mess you up a little bit. And this, you got this whole guy over 2a, and a is 1, so 2 times, I'll put the 1 in there so you can see it. Okay, and then I'm going to simplify this. Opposite of -5 is 5, plus or minus the square root of 25, right? Plus, I have a negative times a negative, that's going to give me a positive 56, I'm thinking there, all over 2. Okay, and then I am going to simplify this, and when I add those together, I believe I get 81. 81 all over 2. Well, what happens here is I have 2 roots, and I know I'm going to have 2 roots because I have a squared term. So I'm either going to have the same double root or I'm going to have 2 roots. Now, the discriminant is talking about roots and what kind of roots they are. So a discriminant, when they ask you about the discriminant, they're only asking you about what are they going to, you know, kind of, what kind of roots am I going to get? Not exactly what am I going to get, but in general, what kind of roots am I going to get? So I'll explain that to you in a second. But right here, what we have is this thing branches off, right? Because I have 2 possibilities. I have 5 plus square root of 81, which is 9, all over 2. And I have 5 minus square root of 81, which is 9, all over 2. Well, this one is going to give me 5 plus 9 is 14 over 2, which is going to give me 7. And here I'm going to end up with negative 4 over 2, which is going to give me a negative 2. So my roots then, in the end, are negative 2 and 7. Okay, and those are my roots. Now that's just a simple quadratic formula. Okay. Now, but I'm going to include discriminant with that, of course. Okay, and these roots, what they are is, there's 2 of them. You got negative 2 and 7, so I have 2. They're real. They're not imaginary. Okay, they're not imaginary, so there's 2 real. 2 real. They're not equal. So there's 2 real, unequal. These roots are rational because it's not pi, it's not e, it's not the square root of anything. So if you have the square root of anything, then you have a situation where you don't have rational roots. So 2 real, unequal, rational. I know I need to move this up, and I will in a second. Roots. All right, 2 real, unequal, rational roots. I gotta move it up some more for you. Okay, is what we have. Now, when we talk about the discriminant, and I'm going to go back up here, the discriminant, a lot of times they ask you about the discriminant because they just want to know what are you going to get? Not exactly, not the negative 2 and 7. They just want to know, are you going to get 2 real unequal rational roots? That's what they want to know. So when they talk about just the discriminant, they're just asking you for kind of this answer. Now the discriminant is just this piece in here. It's just b squared minus 4ac. That is the discriminant. Okay, which is just a part of, it's just a part of the quadratic formula. It's the part under the radical sign. Okay, so the discriminant is the part under the radical sign. I'm going to go ahead and highlight this in yellow. Okay, discriminant is just the part under the radical sign. And all they want to know is, what is the number? Well, the discriminant in this case is, we did what, negative 5 squared minus 4ac. Oh, sorry, I want to put a number in. I'm going to have to scribble. 4 times 1 times negative 14. Okay, and that gave us, in the end, 81. 81 is a perfect square. So if the discriminant is a perfect square, I'm going to get 2 real unequal rational roots. Okay, so perfect square. So, dot, 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 I get 2 real unequal rational roots. So sometimes they're going to ask you just for this. They're not going to want to know, exactly what it is. They're just going to want to know 2 real unequal rational roots. And then sometimes they're going to want to know, what are the roots? So it depends on what they're asking you. If they ask you to tell them about the roots, you're using discriminant. If they're asking you specifically what the roots are, you're going to have to use quadratic formula or completing the square or factoring or something like that. They actually want the answer. So the discriminant, if it's a perfect square, there's two real unequal irrational roots. Okay, but this, with discriminant, is all they would be asking you for. Okay, so these are discriminant notes. These are quadratic formula where I'm actually finding the roots. All right, you got it? I've restated it 50 times. Okay. All right, good. Let's go on. I'm going to show you a few more quadratic formula, discriminant ideas, and then we'll be done. This one's pretty quick. Okay, and then we will put some stuff in our notes on the left-hand side, so we make sure we know what we're talking about. So here I have quadratic formula. You probably can continue on your paper. My papers are a little short. Okay. So sorry, my camera jumps around when I move. Okay, so moving on. So here's another example. We're going to discuss discriminant too. Okay, so I could have something like this. Okay, well, I really can't put it in the quadratic formula. I'm going to have to multiply that out, get everything to one side. Remember, when you're looking for roots, one side has to be 0. So I'm going to multiply this out, and I already know how to multiply this out because this is the difference of squares. So 4x squared minus 1 equals 4x. I'm going to go ahead and move this 4x over. So I have 4x squared minus 4x minus 1 equals 0. I can now put it in the quadratic formula. I'm going to write quadratic formula over here, opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I have the opposite of b plus or minus the square root of b squared minus 4 times a times c all over, and don't forget you're over 2a. I always want to forget that because I'm so excited that I actually wrote this part correctly. So don't forget it, don't be like me. Alright, so what I have is then 4 plus or minus the square root of 16 plus sorry, my notes are all messed up. Okay, so plus 16 all over 8. Okay, so I'm going to end up with, sorry, my notes are messed up. I keep looking at them to make sure if my notes are messed up or I have messed up here. 32 all over 8. And then I'm going to kind of think about that 32 for a second, and I know that I have to fix that up. So 32, my little thought bubble here. Here's a little thought bubble. Square root 32 is really, it's 16 times 2. Square root of 16 is 4, so I'm thinking it really equals 4 square root 2. Right? So I'm going to switch that over, and I'm going to say 4 plus or minus 4 square root 2 all over 8. Well, it looks to me like I can reduce, because each one of those can be reduced by 4. So I'm going to go ahead and reduce each piece by 4. So that's going to be a 1, that's going to go to 1, and that's going to go to 2. So I just reduce them all by 4, and I can do that. What I end up with is 1 plus or minus the square root of 2 all over 2. Alright, so I end up with 2 roots. I have 1 minus square root 2 over 2. I have 1 plus square root 2 over 2. Alright, and that's what I have. And now we're going to talk about the discriminant. Now, this answer here is I have 2 unequal, irrational, because I have a radical in them. Okay, so I have 2 roots. They are unequal. They are real numbers. They're not imaginary. This time they're irrational roots. 2 unequal, and it should have been 2 real unequal irrational roots, but whatever. So that's what I'm going to have. So let's talk about discriminant. And remember, the discriminant is b squared minus 4ac. It's what's underneath. Here it is. It's what's underneath this radical sign. It's not the square root portion of it. It's just that number that's underneath it. And what happens is, when we did this, we ended up with negative 4 squared minus 4 times 4 times a negative 1, and we ended up with this number of 32. So my discriminant was 32. It's not a perfect square, and because it's not a perfect square, but it is a positive number, it's not a perfect square, it's not 0, so I know what I'm going to have then is irrational roots. Okay, so it's not negative, it's not 0, it's not a perfect square, so I have 2 unequal real irrational roots. Okay, and so this is my again, this is my kind of my discussion with discriminant right here on this side. So if they ask you about the roots, you know, what are the nature of the roots, which is what the question will be, what is the nature of the roots? You're going to say, oh, you're going to get 32 for discriminant and say, oh, it's 2 unequal real irrational roots. Or if they actually want to know the roots, then there you go. You're going to have to actually figure them out. Okay, so continuing on. I switched papers already on you. So this is quadratic formula discriminant. And now, you know, quadratic formula we pretty much did, but I need to talk to you about the discriminant. So we're just going to go through 2 more examples and then we're done. So here's another example. Now these are all going to end up being different possibilities for your discriminant, and we get some practice with quadratic formula. Perfect. Okay, so I have an example here. And here's my problem. 4m squared minus 5m plus 3 equals 0. Here's my quadratic formula opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Alright, so I'm going to put it in there. So I have the opposite of b, so opposite of negative 5, plus or minus the square root of b squared, which is negative 5, minus 4 times a times c all over. Don't forget you're all over, like me. I want to just forget about it. 2a. Okay, so I'm going to simplify this. What I end up with is 5 plus or minus the square root of 25 minus 48 all over 8. Or once I simplify that, what I have is 5 plus or minus the square root of negative 23 all over 8. I can't have a negative, I have to pull out its I, so I'm going to pull out its I, and I end up with 5 plus or minus I square root 23 all over 8. Or in my set brackets, what I have is 5 minus I square root 23 and 5 plus I square root 23. Well, if you look at these, you should recognize this. You probably don't, but once I tell you, you're going to go, oh yeah, it is. These are conjugate roots, right? They're conjugates. They're identical, but one's minus, one's plus, right? Conjugates. So what I ended up getting was two imaginary conjugate roots. Now, imaginary roots are always going to be conjugates. Okay, so that's not going to change. So if you get imaginary roots, they're conjugates. Two imaginary conjugate roots. Now, going back to discriminant, because we have to have this conversation. Remember that the discriminant is just b squared minus 4ac. Okay, it's, again, just this piece under the radical sign. And I'm going to go ahead and put in, what I got. So it's just this piece under here. So what we ended up getting, and I don't think I have to go through this whole thing again, is negative 23. So right here, that was my discriminant. See it there? Well, here's my discriminant. Well, they're going to ask you about the nature of the roots. What is the nature of the roots? Well, the nature of the roots is if I have a negative, I'm going to have two imaginary conjugate roots. So if you find the discriminant, you have a negative 23, a negative discriminant I'm just going to means two imaginary conjugate roots. Alright? So if it's negative, that's what you get. So, if they ask you the nature of the roots, you're doing this. And that's it. That's all you have to do is this. Right? If they're asking you the roots themselves, you gotta do that and actually find the roots. Nature of the roots, just that. The roots themselves, that. Okay? That's the difference between quadratic formula and discriminant. Okay, one more and you have done it. Because there's one more possibility with discriminant. Okay, be really quick. Okay, here we go. I'm not even going to title my paper so we don't waste your time. I know your time is valuable. Okay, so here's another example. I have x squared plus 8x plus 16 equals 0. Now, I know you're probably going to look at that and go, but come on, Mrs. Watkins, that's a perfect square trinomial, and I know that. I can just factor and solve. Well, yeah, you could, but I want to show you something with discriminant first, okay? So that's the reason I'm actually showing you this one. So here I have quadratic formula, opposite of b plus or minus the square root of b squared minus 4ac. Hopefully by the end of these notes you'll have that down. All over 2a. Alright, so what I have then is negative 8. This time the 8's positive, so the opposite of a positive 8 is negative 8. Plus or minus the square root of 8 squared minus 4 times 1 times 16 all over 2 times 1. And then what I'm going to end up with is negative 8 plus or minus the square root of 64, that's 64, minus 64 all over 2. Well, 64 minus 64 is 0, right? I'll show that to you. Square root of 0, but square root of 0, oops, sorry, forgot my plus minus, which makes that, it's very important there, is 0. So what I really end up with then is negative 8 over 2, which then I really end up with negative 4. And that's my root. So what I have then is negative 4 as a double root, because I only got one, right? I got one root. It's a double root because I should always have 2 if I have a square there. Okay, so back to our discussion about discriminant. We're almost finished. That the discriminant is just what's underneath the radical sign. And sometimes all they want to know is the nature of the roots. This time, what I ended up with was no square root, forget square root, scribble that out, don't write that down. What I ended up with was 8 squared minus 4 times 1 times 16, or I ended up with 0, right? So if I end up with 0 in the discriminant, and they just want to know the nature of the root, a 0 discriminant means ... 1 real. It's real, it's not imaginary, right? It could be rational or irrational. This one happens to be rational. But 1 real double root. And we'll talk about rational, irrational in class. So this again is this kind of discussion about the discriminant. This one happens to be a rational root because it's not, there's no radical, you know, it's not the square root of something. Okay, so if they ask for the nature of the roots, you just do this. If they're asking for the root itself, you have to do that. So those are the two different things. All right, that is it, and we will talk about this in class.